An important skill needed to traverse academia is the ability to read through and analyze academic journal articles on specific topics related to areas of inquiry. This can be a daunting task for people new to reading academic journals, as searching through the plethora of academic articles and reading through the many pages of dense information can be a lengthy process. Thankfully, reading a paper from start to finish isn't the only path to working through research papers. In this video, we will go over some tactics to speed up the process of determining if a paper is connected to the subject being researched, how the paper can better be digested, and finally we will go through the selection process with example research papers pertaining to the analysis of D-alanine glycine in plants. Unlike reading a typical book, reading an academic article from start to finish is not the only way nor the most efficient way to work your way through it. Instead, utilizing the structure of the paper is beneficial and allows for effective traversal of the information to determine if the paper will be helpful. Most papers follow a structure that includes a title, a list of keywords, an abstract, introductory information or background on the paper, the experimental section, the results obtained, a discussion of the results, and a summary with conclusions drawn from the experiment. Tables and figures with captions will be placed throughout the paper, and a list of references corresponding to the articles referenced by the author will be footnoted and placed at the end. The title and keywords will be a major aspect of how the paper is cataloged by the research article archive used and will correspond to the search terms used in finding the paper. In deciding if the paper is one tied to your subject, the title and keywords will be the first place to look. For our example of the analysis of alanine glycine in plants, you may find papers that contain the searched for key terms, but the title of this paper, as an example, is focused on the activity of D-alanine glycine endopeptidase in bacteria. This paper may not be helpful to our current task, and another should be considered. However, the title of this paper shows that it is tackling the subject we are looking into specifically. Even though the title may suggest the paper pertains to our subject, our next step is to read through the abstract if the paper has one. This section will give you an overview of the paper, along with a brief on the results. If the paper does not have an abstract, reading the summary and conclusions of the paper at the end will similarly give you an idea of where the paper's research focused and will tell you if the paper pertains to your specific subject. With the example of the analysis of D-alanine glycine, looking at the conclusion of this paper shows that it does pertain to the item of research, as it states that a modified AAPAC method can be used to analyze it in rice. Looking to tables and figures can also help with identifying if the information covered in the paper pertains to your subject. As we can see, this graph pertains to the analysis of D-alanine glycine. Once it is decided that the paper is not only tangentially related to the desired subject, but covers the needed information, returning to the introduction and reading the paper through with greater depth is the next step. The introduction will give background as to why the research is being conducted and what led to the method of inquiry. For this paper, the stated reason for conducting the research was to ascertain the function of the observed D-alanine glycine found in rice. As you finish reading the introduction and start to dig into the meat of the paper and the results and discussion, take notes on key takeaways as well as any subject you may need to look up to better understand what is being stated. If the paper contains footnoted references to information that seems pertinent or to subjects you think you need to research to better understand, take note of this and the paper referenced in the references section as an area of further inquiry once the paper is read through. We can see here that in this paper there's references 4, 5, and 7, which can lead us to see how large quantities of D-alanine in the form of D-alanine glycine have been found in the leaf blades of rice. As you get into the results and discussion, you may find you have gotten the information needed for your inquiry and may not need to dig into the experimental section. However, for papers strongly tied to your subject, the experimental section can provide insights into how the data was obtained and give details on how they came to their conclusions. Additionally, by following references and seeking further information on areas we are unfamiliar with, we can discover further background on how D-alanine glycine was discovered in rice and why it is an area that needs further research. Now that we have gone over tactics and methods for quickly going over research articles, let's do a quick read-through of our example paper. As a quick background prep, let's go over how one of the major components of this paper, HPLC, works. High-performance liquid chromatography is a method for separating the components of a solution by running the sample across a column filled with a high surface area packing material, used to separate the components of the solution. Depending on the type of HPLC being run, the stationary phase can be made of different materials, and the mobile phase used to pull the material through, differing based on how the target molecule is binding to the column. In our paper's case, ion exchange chromatography, specifically cation exchange, is used, meaning the column is packed with negatively charged beads that bind tighter to positive components of the solution. This will cause the negatively charged materials to flow through first, with less positively charged particles eluting faster. The pH of the mobile phase buffers will be changed, as this will cause the target molecule's net surface charge to be affected, altering its binding affinity to the column. Our paper uses a citrate buffer of increasing pH, followed by NaOH to clear out remaining molecules. The eluted molecules will flow through a detector which measures the electrical conductivity of the solution, with the data gathered being used to generate a chromatogram showing peaks of changes in the electrical conductivity. By analyzing the chromatogram with an understanding the sample component's retention time on the column, the amount of the component can be found using the area under its peak. We have already determined this paper is pertinent to our subject, so we will start with digging into the details. In the background, we find that first 2D paper chromatography was conducted. However, the D-alanoglycine spot overlapped with the alanine spot on the chromatogram. Following this, HPLC was conducted, which found that D-alanoglycine tended to overlap with methionine and isoleucine due to the short elution time, as well as overlapping with the metabolite of feeding the plant's D-alanine, which is alanine-alanine. To resolve the methionine and isoleucine peak overlap seen in the previous experiments, the authors used a different method to elute the analytes, which successfully shifted the D-alanoglycine peak between methionine and isoleucine, but further separation of peaks was needed. To achieve this, the pH of the solvents was altered to further separate the peaks. Due to the alanine-alanine peak overlapping with D-alanoglycine, alanine-alanine was eluted and the temperature lowered to find a baseline for comparison. Different parts of the D-alanine-fed rice plants were eluted, and it was found that the D-alanine was mostly found in the rice plant's leaves. The researchers found that alanine-alanine, D-alanoglycine, and isoleucine still overlapped. To try to resolve this, temperature was lowered for the analysis, and greater separation was achieved. The separation was not complete enough for an accurate determination of D-alanoglycine, but the authors suggest that the PPC method may be helpful to gain an accurate amount, where 2D chromatography is undergone, as it successfully separates the D-alanoglycine and alanine-alanine, and HPLC being run on the results of this. Ultimately, the paper found that the altered AAPAC method was successful at detection and rough estimation of the D-alanoglycine, and for plants not fed D-alanine, D-alanoglycine could be accurately determined. With this, you can see that the identification of papers pertinent to a specific subject, as well as the process of obtaining useful data from said papers, does not have to be an overlong process. And for those looking to learn more about our example of D-alanoglycine determination, I hope this dive into this paper was helpful.